Hello, class. Today we are going to start Chapter 2, which is an introduction to logic. And we're going to begin by talking about conditional statements. So here we are, conditional statements. So first thing we got, a conditional statement is a statement that has two parts. It has a hypothesis and a conclusion. Generally speaking, these will be written in if-then form, okay? On this condition, then that is true. So if this, then that, okay? And the way it's done is if the hypothesis, then the conclusion. And when we do this, we use P for the hypothesis, and we are going to use Q for the conclusion, all right? So we have if hypothesis, then conclusion. So if P, then Q. And it is symbolized with this little symbol here, P arrow Q. And the way that is read is that P implies Q. If P is Q, that implies that Q is also true. All right? And a lot of things can be turned into if-then sentences, into conditional statements, just by anchoring an if and a then. For example, we have this statement right here. American teens spend 9 hours a day using media. All right? So we want to turn this into an if-then statement, which means we need to figure out, okay, what is the hypothesis, what is the if part, and what is the conclusion? All right, what is the then part? So what we're going to do here, we're going to take this, and we're going to have this first part. This teenager is American. All right, so if we have an American teenager, so if a teen is American, if a teen is American, then they spend 9 hours a day using media. All right, so then they spend 9 hours a day using media. That is our conclusion. They spend 9 hours a day using media. All right. So if our hypothesis is true, then the conclusion is true, hopefully. Right? Now, is this a true statement? Is it true that if a teen is an American, then they must spend 9 hours a day using media? Well, no, it's not. Not the way it's worded here. This says that it's never fails, right? But there are teens who are Americans and they only spend 8 hours a day or 7 hours a day, or maybe they spend 11 hours a day using media. So that makes this an untrue statement. Now, it could be made true by saying, on average, American teens spend 9 hours a day using media. Then it might be true. I don't know. I'd have to look at the stats. But then it sounds good. Or most American teens, or some American teens. Then it would be okay. But the way it is here, that is a not true statement. But if then, you have if hypothesis, then conclusion. Notice the hypothesis is not if a teen is American. The hypothesis is simply a teen is American. The conclusion is not then they spend 9 hours a day using media. The conclusion is simply they spend 9 hours a day using media. The if and the then are not part of the hypothesis or conclusion. They go in front of them. Next thing we do want to look at here is negation. All right. Negation means the opposite of what you said. So it means the opposite. So not that. So not P. Okay. And the symbol we use for not P is we use this little squiggle right there. That means not. Okay. So here we have the statement, cats are born with their eyes open. The negation of that would be to say that's not true, and we could say that by saying cats are not born with their eyes open. All right. Cats are not born with their eyes open. Now, one thing I do need to make clear, if the example had been cats are black, right, or the cat is black, the negation of that would not be the cat is white. Oh, but black is the opposite of white. No, it's not, actually. The opposite of saying the cat is black would be to say the cat is not black. All right? It's not complete opposite. It means it's just not that. Whatever you're saying there, that's not true. It could be just about anything else, but it's not that. So if the example is the cat is black, was it? No, it's not black. And just because it's not black doesn't mean it has to be white. It could be brown or gray or pink, purple, I don't know. It just can't be black. Now, one thing we want to look at before we go on to some of the more other things, we do want to look at truth tables. So is this a true statement, is it not? So what we have here, we have a truth table. The conditional statement is right here. So this is my conditional statement. So this is conditional. What's this? So we have an if and then. So we need to specify hypothesis. We need to specify conclusion. So if P, then Q. So the hypothesis, here we have our statement. If you pass the test, then I'll take you out to eat. So the hypothesis is just this part here. What did I use for that? I used right. Okay. You pass the test. That is the hypothesis, okay? That is P. The conclusion, then I'll take you out to eat. The conclusion is just, I'll take you out to eat, all right? Not the then, just that. Okay, so that is Q. So now, what we're going to do is we're going to put together a truth table based on this hypothesis, this conditional statement. Okay, so we have P, we have Q, and then we're just going to test this statement here. P implies Q. So if P, then Q. All right, so let's look at this. Lots of different things could happen here. Option number one. All right. They are both true. All right. That is one thing that could happen. We're going to do it like this. All right. You really did pass the test. And I really did take you out to eat. So is my statement that if you pass the test and I take you out to eat, is that a true statement? Well, yeah, that's true. All right. Now, there are other options that could happen here. For example, hypothesis is true. You passed the test. And yet, I did not take you out to eat. So, did I lie to you? Did I make a false statement? Yeah, I did. Because you did pass the test. You held up your end of the bargain, but I didn't hold up mine, right? So, that is false. I was a big fat liar. No good. There are other options here. It could be that you failed the test. All right? Hypothesis is false. But I'm a nice guy, and I still took you out to eat. Is my statement that if you pass the test, then I take you out to eat false if I took you out to eat anyways? Well, no, it's still true. If you'd passed the test, I would have taken you out to eat, but I also took you out to eat when you failed it. So this is still true. All right? In order for this to be false, the hypothesis has to be true. Because other options, there's only one other option here. You failed the test, and I did not take you out to eat, so that is also false. So if you failed the test, but I didn't take you out to eat, did I make a true statement when I told you that if you passed, then I would take you out to eat? Well, yeah, as far as we know, because you didn't pass, and so it has no bearing on what I do after that. So this, I still made a true statement. If you had passed, I still would have taken you out to eat. So what we see here is that in order for a statement to be false, the hypothesis must be true and the conclusion must be false. All right? If the hypothesis is not true, then we have to assume that the statement is true because, hey, if you had have passed, I still would have taken you out to eat. I was still telling the truth. All right? Well, no matter what you did when you failed, I was still telling the truth. Okay? All right. Now, jumping back over to conditional statements. There are other things we can do with conditional statements. First, okay, so the conditional statement is if P, then Q. Now we can mix that up and we can have converse. All right, so let's take a look at converse. All right. The converse is if we take it and we switch the hypothesis and conclusion. So instead of having if P, then Q, what we're going to say here is if Q, then P. All right. So our statement here, we have the statement, if you've toured the U.S. Capitol, then you've been to Washington, D.C. All right? So let's see here. The hypothesis, you have toured the U.S. Capitol. The conclusion, you have been to Washington, D.C. You have been to Washington, D.C. Now, first off, is that a true statement? Well, yeah, because the only way you could be inside the U.S. Capitol building is if you're in Washington, D.C., because that's where the Capitol building is. Now, what we're going to do is we are going to change the order of this. We are going to make the converse. So what we have here, it still starts with if. But then we're going to take these and we're going to switch them. So we have if you have been to Washington, D.C. You have been to, I'm going to run out of room, so I'm just going to say you have been to D.C. If you have been to D.C., then you have toured the U.S. Capitol. Then you have toured the U.S. Capitol. Well, this is the converse. All we did was we just changed the order, all right? Now, is this a true statement? Well, not really. I've been to D.C. more than once. I have never set foot inside the Capitol building, ever. So I have been to D.C. That part is true, but I have not toured the U.S. Capitol. So what we have here, my hypothesis is true, but my conclusion is false, and so this is a false statement. So this is a false statement. That is a converse. All you do is you just take it and you switch the order out. That's it. Next thing we could do with it is we could take the inverse. And the inverse is saying, no, not that. Not going to work. What we're going to do here is we are going to negate both the hypothesis and the conclusion. So here we have the same original sentence. We have, if you have toured the U.S. Capitol, then you have been to Washington, D.C. So same hypothesis, same conclusion, but we're going to say not that on both of them. No, neither one of those. So if the negation of you have toured the U.S. Capitol would be you have not toured the U.S. Capitol. So if you have not, let me do that. If you have not toured the U.S. Capitol, toward the U.S. Capitol, there's my hypothesis. I did these in backwards. Yeah, no, the same. Right. We're not changing the order, So if you have not toured the U.S. Capitol, then you have not, we're going to negate both of these, been to Washington, D.C. Yep, I'm going to been to D.C. Is that a true statement? Is it true that if you have not toured the U.S. Capitol, then you have not been to Washington, D.C.? No. As I've already said, I have never set foot inside the U.S. Capitol, but I have been to Washington, D.C. more than once. I got family up there. So this is a false statement. Actually, you know what? Let's go ahead and what did I do? We'll just do this. Okay, so the original statement is true. If you toured the U.S. Capitol, then you must have been inside D.C., because that's where the Capitol is. The converse here is false, and the inverse was false. All right? Now we're going to look at another one. What happens if we switch the order and we say, no, not that, we negate it? Then we end up with what's called the contrapositive. All right? So that's what the contrapositive is. It is basically the inverse of the converse, or the converse of the inverse, whichever way you like it. This is saying we're going to switch the order and say not that. So instead of having if Q then P, we have if not P, then not Q. Oh, sorry, instead of having if Q then P, this is all backwards. Where's it at? There it is. There you go. If P then Q, we're going to switch the order like the converse, Q then P. Then we're going to say not Q, then not P. So this was wrong. This is messed. That's what messed me up. This should be if not Q, then not P. There we go. There we go. Now I'm good. So we have the same sentence. You have toured the U.S. Capitol, then you've been to Washington, D.C. So my hypothesis and my conclusion, those are the same. And what we're going to do, we still start with if we switch the order. So if you have been to Washington, D.C., that's going to go first. If you have, except we're going to negate it. Negate it. So if you have not been to Washington, D.C., if you have not been to D.C., then, no, need a comma, then you have not toured the U.S. Capitol. You have not toured the U.S. Capitol. Toured the U.S. Capitol. All right, so is this statement true or false? Let's see, if you've never set foot in Washington, D.C., you've never been in the entire city, could you have possibly gotten inside the Capitol building? Well, no, because the Capitol building is inside Washington, D.C., right? So this is true. If you've never been to D.C., then there is no way you could possibly have toured the Capitol building. Now, one thing I do want to point out to you. Notice, the original conditional statement and the contrapositive are both true. The converse and the inverse are both false. These two will always agree. These two will always agree. So the conditional statement will always match the contrapositive. Those two always agree. And these two always agree. Every time. Now, most of the time, these two will disagree with the other two. The converse will be true and the conditional will be false. Or the conditional will be false and the converse will be, or the conditional will be true and the converse will be false. Usually, these two are opposite each other, but not always. All right? And in those rare instances when they both work, we have what's called a biconditional statement. All right? For example, if a polygon has 3 sides, then it is a triangle. Right? So my hypothesis, a polygon has 3 sides, then it is a triangle. So my conclusion, it is a triangle. That's true, right? If you got a shape, it's got 3 sides, it's a triangle. What if we flip that around? If a polygon is a triangle, then it has 3 sides. Is that true? Yeah, it is. So we see the conditional statement and the converse are both true, so we call this a biconditional statement. And what we can do with that, And all definitions are biconditional statements. What we can do with that is we can write it as if and only if. So P if and only if Q. And the symbols there, you see, we've got the arrow going both ways. So P implies Q, Q implies P. All right? And so what we're going to do is we're going to rewrite this as a biconditional statement. So we start with a hypothesis. A polygon has three sides. A polygon has three sides if and only if and only if it is a triangle. And that is a biconditional statement. I could flip it around. If a polygon is a triangle if and only if it has three sides. And it still works, doesn't it? Yeah. So definitions, all definitions are going to be biconditional, and we can write them that way. All right? So there it is. Conditional statements, if-then sentences. A negation says not that. The cat is blue. The cat is not blue. All right? Converse is if you take your conditional statement and you just change the order, right? So if P, then Q. If Q, then P. All right? Inverse, not this, not that. Okay? Inverse is not that. The negation of both of them. Contrapositive, you do both. You flip the order and you say not either one of them. Biconditional, it's true if and only if. And this is when the conditional and the converse are both true, then we have a biconditional statement. All right? And don't forget our truth tables over here. Something is only false if the hypothesis is true and the conclusion is false. Any other case, then we have a true statement. All right? All right, so that's that, and I hope you found that useful. I'll see you in the next video.